Welcome to the 23rd door of our MBSE Podcast Advent Calendar. Today, we show you some more aspects of the next generation modeling language, SysMLv2.
Yesterday, we showed a simplified physical architecture of our Christmas tree in SysMLv2. Today, we will briefly look at requirements, the modeling of variants, and the SysMLv2 API. First, let's open our Jupyter Notebook again.
A quick reminder of what we already have. It is a simple physical architecture that specifies the parts of our Christmas tree and their connections.
Now we look at the requirements. We import a part of the requirements from the International Christmas Tree Standard ICS 242526-12, which is modeled here with only one requirement.
The ICS 242526 requirement rec_tree_height is a requirement definition. It specifies the name rec_tree_height, the requirement text after the doc keyword, and an attribute tree_height to formally specify the constraint that the height of the tree must be between 150 and 200.
In the package tmpct_requirements, we use the defined ICS 242627 requirement. Our tmpct requirement height of the tree is a usage of the requirement definition rec_tree_height. In addition, we specify a requirement ID rec1 and redefine the tree height attribute by setting it to the value of the appropriate value property of our Christmas tree.
The visualization of the requirements is not very exciting, among other things because we have not used relationships.
Next, we have a brief look at how to model variants, because this is a hot topic in MBSE. First, we take our tmpct physical architecture again.
The variability is defined in two additional packages. In the tmpct variations package, we define an abstract Christmas tree variations part that contains the variations which constrain the allowed variants. The keyword and concept variation in SysMLv2 is similar to the concept of a variation point. For example, we specified that our part Christmas tree star can have one of the three variants Echo Star, Premium Star, or Standard Star.
We also defined another variation for the part Christmas tree stand. In addition, we defined a constraint that specifies if the Premium Star variant is selected, you must select the Large Stand variant.
The variants are defined in another package, tmpct variants. Very simple, we just defined the parts. Only the Premium Star part owns another part LED light.
The visualization of the model depicts some new special SysMLv2 notation elements for the variants. It shows the specified variants of a variation by a relationship.
Finally, we defined two products of our MBSE Podcast Christmas tree. The Echo tree subsets the abstract part Christmas tree variations and selects the Echo Star and the Standard Star variants. The Premium tree selects the Premium Star and the Large Stand variant.
We close this episode with a brief look at the SysMLv2 API. We can publish our model to a SysMLv2 repository server, which is provided by the company Intercax. To have everything in one model, we put all our previous packages into one package called tmpct.
The publish command posts the model to the Intercax server, where we can access our model via the SysMLv2 API.
Through the Swagger UI, you can use the API in the browser. As an example, we show how to view the list of projects in the SysMLv2 repository. With the project number, you could then get to the commits via the API and via project and commit number, then the elements of the model.
So much for the 23rd door of our MBSE Podcast Advent Calendar, and we wish you a great 23rd of December. Bye-bye.
Bye.